congruency. So we learned in 5.1, in order to prove two triangles congruent, all three sides need to be congruent to three sides in the other triangle, and then all three angles need to be congruent to three angles in another triangle. There are shortcuts to that. So to prove triangles congruent, there are 5 shortcuts. The triangles can be proven congruent using the following congruency postulates, where S stands for side and A stands for the included angle. Or for right triangles, HL, where H stands for hypotenuse and L stands for leg. So the biggest thing to remember here, with the exception of right triangles, you need 3 pieces of information. If you do not have 3 pieces of information, then you cannot prove the triangles congruent. Again, that is with the exception of right triangles. So here, side, 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 which means all 3 sides can be congruent to all 3 sides in another triangle. So 1 congruent side, 2 congruent side, 3 congruent sides. So that means that we have side, side, side. And again, the order matters on how you name them. So A down to B. So I'm going to start here. A is made up with the 3 congruent side and the 1 congruent side. So I need to start with D and go over to E. So triangle DEF. Over here, side, angle, side. That is where we have 2 congruent sides and the angle in between them is congruent. So if you need to, write it out. So here's a side, here's a side. I have an angle right here, and then another set of congruent sides. So you can see a little bit better. We have SAS, SAS. I'm not skipping over any sides or any angles, and it's the included angle. So then triangle ABC, so triangle XYZ. And then I have angle, side, angle, where now I have 2 congruent angles and the side in between them is congruent. So here I have congruent angle and congruent angle, and then a congruent side and a congruent side, congruent angle, and congruent angle. Messing up on how I write this, but ASA, ASA, so triangle ABC, I'm starting at the angle with 2 arcs, and I'm going down the side that's congruent. So starting at the angle with 2 arcs and going down the side that's congruent. So that means that triangle WYZ. WYZ. Angle, side, and then here I have 2 angles and a side that's not included. So angle, angle, and then another angle here, and a side, side. As you can see, if I go all in a row, I have AAS, AAS. And you can say this is SAA. That's okay if you flip the order, but just realize it's more commonly known to put AAS, but I wouldn't mark it wrong if it was SAA. So triangle ABC, I'm starting at the angle that has no arcs to it. So A down to B, so LEF. So triangle L, E, and F. And then this is HL, and it is for right triangles only. That is super important. Do not try to use HL on triangles that are not right triangles. So here, hypotenuse, leg. Remember, the hypotenuse is always across from our 90-degree angle. So this is my H, my hypotenuse, and then I have a leg congruent. So I have HL and HL. So those 2 triangles are congruent. So ABC, starting at the angle that is made up of 1 congruent mark and 2 congruent marks, so 1 and 2. So D, going down the hypotenuse side, so DEN. So triangle DEN. Now the one, there are 2 where people get mixed up. So side angle, SSA, or angle do not work. Okay, so we put a picture of a donkey here, and then any triangles with all three angles marked congruent will not work. So those are the two you have to be very careful for. SSA and AAA, they will not work. Okay, so here, moving on to, are the triangles congruent? If so, what is the postulate that was used, and what about the congruent statement? So here, there are many different pieces of information that we can pull from this triangle. First, we're dealing with parallel lines. You cannot forget about your relationships between angles. So I can say that these two angles are congruent. So angle 1 is congruent to angle 2 by alternate interior angles. Notice I can only use alternate interior angles when I know that those two lines are parallel. Okay, and you can't forget about those angle relationships, because now we're really going to be pulling a lot of different information from the previous sections. Alternate interior angles, vertical angles, a lot of that stuff is going to come together, and you need to be able to recognize that just because you're given that these two sides are congruent doesn't mean that you're done. So here, again, if you need to, if you're having trouble recognizing, so we have side, angle, side, and then side, angle, side. So yes, these two triangles are congruent by side, angle, side. To write my congruent statement, I'm going to say triangle S, well, let's go SPR. Triangle, I started at this angle, so I got to start here, so QPR. Notice how in my first statement right here, the order of this triangle doesn't matter as long as you follow the same order in your second set of letters. For B, here, as you can see, this one side was shared between the two triangles. We have a shared side right here as well. The two triangles are laid right on top of each other. So I can say that this side is congruent in both triangles. So I can say the RT is congruent to RT by, remember when something's looking in the mirror at each other, it's the reflexive property. So again, now I have an angle, angle, side, angle, angle, side. So this triangle is going to be congruent by angle, angle, side. So triangle, let's do URT is congruent to, it started with U, which is one arc, so S, which is one arc, so SRT. I've always been putting my triangle symbol there because, as you notice, you can also use 3 letters to name an angle, so you need to tell me that you're actually talking about the triangle, so always put your triangle symbol there. And I like to write that we proved RT is congruent to RT by the reflexive property. Get in the habit of writing that stuff down, because if you don't, then you might start getting confused. So flipping it over on the back here, again, if you need to, start writing things out. So I have a side here and a side there. 2 dashes match up with 2 dashes, so another 2 sides. Then side and side. Since I have 3 S's, that is one of our theorems, so this one is side, side, side. Triangle ABC is congruent to triangle, if I started right here at A, I need to start at E, and I went down the side with one mark, so EFD. EFD. For D here, again, they're sharing this side, so I'm going to say that side's congruent and say that CA is congruent to CA by the reflexive property. Again, please start writing this stuff out. If you do now, it's going to make the proofs section of this a lot easier. So now I have a side here, side there. These all have 1, so there's my 2 sides. And I have a side right here in the middle. So this one is also side, side, side. And I can say that triangle ABC is congruent. So I went ABC, so ADC right there. All right, another big common one that we are going to use in this section, I told you reflexive property is going to be 1, alternate interior angles is going to be 1, and vertical angles, so angles that are directly across from each other, is going to be another big one. So here I can say that this angle is congruent to this angle. So let's name this. So angle RTS is congruent to angle UTV by vertical angles. Once I'm done here, I'm going to go ahead, just in case you still need help figuring out what theorem it is. We have 3 pieces of information, so I'm going to say this is an angle, I have an angle here, and that matches up with that angle, and a side here, side here. So if I go all in a row in a triangle, I have AAS or AAS, and that is one of our theorems. So I'm going to say these triangles are congruent by AAS. Triangle, let's start up here. So RTS is congruent to triangle UTV. Again, be careful with that ordering. The order of these matter. Okay, so for F, I know that this is my hypotenuse, so I'm going to mark this H and H just in case. And then these are back to back, so I'm going to say that CD is congruent to CD by the reflexive property. Now I have a leg here, so this is going to be HL. I'm dealing with a right triangle. I can see that by that symbol, right triangle. I have my hypotenuse congruent to my hypotenuse and 2 legs congruent. So triangle ADC is congruent to triangle, again, I started here, so I'm going to be BDC right there. For G, I'm given that my hypotenuse is congruent to another hypotenuse. However, I'm not given any other information. I'm not given that lines are parallel, so I can't do anything with alternate interior angles or corresponding angles. I'm not given that M is the midpoint. I'm not given any other information. So here I'm just going to say not congruent. We are not given enough information on that to prove. I'm only given 1 piece of information where I either need 2 for a right triangle or 3 for any other triangle. Again, here, 2 triangles back to back, I automatically see vertical angles. So angle DEC is congruent to angle BEA by vertical angles. Now again, I have a side and a side, angle and an angle, side and a side. So I can see a little bit better if I go all in a row in one triangle. I have SAS, SAS. So this triangle is congruent by side, angle, side. To name the triangle, ABE is congruent to, let's do CED. No, I didn't do that right. I went A to B, which is along this long side right here that's not marked. So CDE. There we go. Few more left. So for I, again, I see a side that's being shared. So 3 markings because I've already used one of them. I've already used 2. So side PM is congruent to side PM by the reflexive property. And then if I look, I have a side, and then this side's being shared. So I see 3 S's, which automatically means side, side, side. So triangle, let's start up here, MNP. MNP is congruent to triangle MQP. J, again, I see a side that's being shared, so I'm just going to put 1 dash here because there's 2. So AC is congruent to AC by the reflexive property. But my problem is here, if I have a side here, congruent, side congruent, side congruent, side congruent, I am not given any other information about this. I only am given 2 pieces of information. I'm not working with a right triangle, so this one is not congruent. Then down here, automatically, again, you're going to see this a whole lot. This side's being shared. So QR is congruent to QR by reflexive property. Then I'm also seeing I have right here and right here. Remember, those are the symbols for parallel lines. So these 2 angles are congruent, but then I can say these 2 angles are congruent. So angle PQR is congruent to SRQ because they are alternate interior. Oops. Oh my gosh. Angles. Remember, and this is one big thing that I saw, you can only use those angle relationships of alternate interior angles, alternate exterior angles corresponding. You can only say that they are congruent when you know your lines are parallel. My lines are parallel here, so I can say that those 2 angles are congruent. So now I have an angle and an angle. I have a side, and an angle and an angle. If I go in a row all in one triangle, I have angle, side, angle, angle, side, angle. So this is angle, side, angle, and triangle PQR. Started up here at this P that has nothing on it. Go over to my angle that has 2 arcs, so it's congruent to S. Go over to my angle that has 2 arcs, so SRQ. And then last one. So for this one, we have vertical angles automatically. So this angle and this angle. So I'm just going to put it, let's do it right here. Angle BABE is congruent to angle CBD by vertical angles. Okay, and then if I go in a row, I have a side here, side, side, angle, angle. Okay, so this would be SSA or ASS, and that is no good, so not congruent. Remember, bad words are not allowed.